Reasons of myopia we have discussed. So basically what happens in a myopia, if this is the object at distant, this is a distant object and this is the myopic eye, and this eye want to see this object. So basically from the distant object I have told you rays will be parallel. So these are the parallel rays, and these parallel rays will enter into the eye, and these parallel rays will be converged by the eye lens, okay, at this point. Basically these rays are converging at this point, so means you can say the image is formed at this point, but the image here is forming in front of the retina, and for the vision, for the clear vision of the image should form on the retina, okay. So here the image is forming in front of the retina, so that is why the person is not able to see the see the object clearly. So here what happens in myopia, basically uh, converging power becomes high, or you can say the focal length of the eye lens becomes less, okay. Now correction of myopia. So basically if an object is at the far point of the eye, then this object can be seen clearly by the myopic eye. Basically this is the eye suffering from myopia, and this is the object, and this object is present at the far point of this myopic eye, okay. So if the object will be here, then the image will form at retina, and this myopic eye can able to see the object clearly. Now basically in the correction we use this concept. What we do, basically this is the object and this is the myopic eye, and this eye want to see this object. So from this object the rays will be parallel, okay. If this lens is not there, then the image will form in front of the retina we have discussed, okay. So what will happen here, in between the object and the eye you have placed a convex lens, a concave lens, okay, and concave lens you know is a diverging lens, okay. So rays are diverged by the concave lens. So basically from this object the rays will be like this, rays will be like this. These rays first strike with the concave lens, and refraction will take place, and there will be some diversion of these parallel rays like this. There will be some, these are the earlier the parallel rays are the, these, in front of these there is a concave lens. So due to that concave lens there will be some diversion, so the parallel rays will become like this, something like this, okay. So these this is the diversion. So we know that when we will produce backward these diverging rays, so we will get the image, we will get the virtual image of this object at the far point. This is the important point, at the far point of this eye, at the far point of this eye, and this is the virtual image because we are just producing backward these rays. And now here is the image of this object, and that image is the virtual image of the object. So basically this image for this eye lens now will work as an object. So of this image, or you can say object for this lens, there will be the image on the retina. So the condition is that uh, the diverging lens should be placed in such a way, or the concave lens should be placed in between the object, in between the distant object and the myopic eye in such a way so that the image of the distant object should be formed at the far point of the myopic eye, okay. If the image is at the far point of the myopic eye, that image will work as an object for the eye lens, and eye lens is able to just form the image on the retina. If the image is formed on the retina, then we can see, that eye can see clearly. Okay, so basically correction of the myopia, the concave lens placed in front of eye forms a virtual image of the distant object at point F. F is the far point of the myopic eye. Okay. Image at F will behave as an object for eye lens, and due to that the image of the object will form that retina. So basically this is the first eye defect, that is myopia. After that there is another eye defect, hypermetropia. Basically in myopia the person is able to see the object, see the in myopia the person is able to see the nearby object clearly, but the distant object he or she cannot see clearly. But in hypermetropia the case is opposite. The distant object the person can see clearly, but the nearby object cannot be seen clearly by the person. And what are the reasons? Earlier what were the reasons in case of the myopia? Due to short focal length of the eye length. So the eye length there in the myopic eye, okay, so focal length of that eye length becomes less. But in case of hypermetropic eye, the focal length of the eye length becomes large, and due to that the converging power, of the eye length becomes small. And if you want to see, if that myopic eye want to see the nearby object clearly, and from the nearby object what type of rays we get, diverging rays. So to converge the diverging rays, there is a requirement of high converging power, but here the converging power becomes low. Okay, so whole story is written here. Hypermetropia. Hypermetropia is basically also known as long sightedness or far sightedness. Basically this is a person, and this person is want to read the text in this book. Okay, so basically this book is at nearby of this person, so this person is not able to see the text clearly. Okay, because this person is suffering from hypermetropia. Okay, this person is suffering from hypermetropia. So basically hypermetropia, defect of eye due to which a person cannot see the nearby object clearly. Okay, so basically this image I am just removing, no need of this. So basically you understood now what is hypermetropia. The nearby object the person cannot see clearly. Okay, so hypermetropia we can write it is the defect of vision due to which a person cannot see nearby object clearly. Though he or she can see the distant object clearly. Okay, can see the distant object clearly. What happens in hypermetropia? Azaan, can you tell me what is the near point for a normal eye? for a
Sir,
normal eye.
25 centimeter.
Hmm, hmm. But in this case, na, in case of the hypermetropic eye, the near point of the eye becomes more than 25 centimeter. Okay.
Okay, sir.
So here in this case, near point of hypermetropic eye is more than 25 centimeter away. What are the causes? Number one, first cause is basically due to the large focal length of the eye lens. Okay, you can say due to large focal length of eye lens. So in eye lens, what happens? Due to some reason, there can be n number of reasons. The focal length increases of eye lens than the required value. So basically, focal length can be adjusted by the ciliary muscle. So you can say there can be a defect in the ciliary muscles also. Okay, ciliary muscles becomes weak, and if focal length is large, so you can say power is equal to 1 upon focal length. So you can say another way, you can say due to the large power, focal length become large, so due to low converging power of lens. So you can add one more point, due to low converging power of eye lens. And there is another reason. In case of the hypermetropia, the eye wall becomes too short. Okay, due to eye wall becomes too short. Two reasons are there. Okay, now I will tell you the whole process, what is happening. Basically, this is the basic definition and the reasons why the person suffers from the hypermetropia. Okay, so okay, what happens? Suppose there is a person having the hypermetropia, and in hypermetropia, what happens? Suppose my I have the hypermetropia. Suppose, okay, and this pen is at a distance of 25 centimeter. So can you tell me, can I see this pen clearly if this pen will be at a distance of 25 centimeter?
Yes, sir.
No, clearly I cannot see.
Yeah, yes, sir. Clearly you can.
I have just mentioned the word clearly. I can see, but I am saying that clearly I cannot see this pen. So what I have to do, in case my eyes is suffering from hypermetropia, so the near point of my eye will increase. So I have to increase the distance of the pen so that the pen is visible to my eye. So basically, this is the point uh, from my eye, or you can say this is the distance from my eye at which the pen is placed, and this pen is now I can see clearly. And if I am placing this pen here, so my eyes are not able to see this pen clearly. So this is the case here discussed. Okay. So this is the nearby object. Okay, this is the nearby object. Nearby object means this object is placed, and this is a myopic eye. This is a hypermetropic eye. Okay, this is the hypermetropic eye, and this is the object. And this object, suppose, is placed at a distance of 25 centimeter. So if you want to see an object which is this eye want to see an object which is at a 25 centimeter, which is at a 25 centimeter. So in this case, what will happen now? You know that uh, the converging power, okay, the converging power of this eye lens becomes weak, okay, or you can say converging power becomes small, and this is the nearby object. This is the nearby object, and from the nearby object, what type of rays will be there? Diverging rays. And to converge the diverging rays, this eye lens will not have the sufficient converging power, so that this eye lens can converge the rays at the retina. Okay, these rays will not converge at retina. Instead, these rays will converge beyond retina, behind retina. So here basically the image will form. Here will be the images form, and this image is not on retina, so there is a problem. Okay, and what happen if you will place this object? If suppose I have placed this object here, this is the object, and I have placed this object at a distance from this eye, which is at a uh, near point of this eye. So where the image will form? The image will form like this. Image will form on the retina. Okay. If the object is at near point, the image will form behind the retina. Okay. And from the nearby object, what type of rays we get? Diverging rays. This is another diagram. Just I have explained here. This is another diagram. This is the retina basically. This is the normal point. Okay. What is the meaning of normal point? Means this distance will be 25 centimeters. So if the object will be here, okay, at the near point of this hypermetropic eye, okay, near point of this hypermetropic eye, then the image will form on retina. Means if somehow the image is somehow the object is at near point, okay, then this eye can able to see the object clearly. Less than this eye is not able to see the object clearly. What is the correction then? What is the correction? So you can think correction by yourself. This lens have the low converging part. This eye lens, due to the long focal length, have the converging power low. Means the converging power becomes low. So basically, what you have to do now, you have to increase somehow the converging power of this. You have to just not increase the converging power. Basically, you have to just diverge these rays. Okay, you have to just diverge, or you can say you can just help this eye lens to diverge these. Uh, sorry, you have to basically what you have to do. These are the diverging rays. So this lens is converging these diverging lens, diverging rays. So somehow you have to help this lens to converge these diverging rays. So how this will happen? You will place a converging lens. Okay. So basically, this is the basically myopic eye, hypermetropic eye, and this is a converging lens you have placed. Okay. Now, here is the object that you want to see. Basically, this is the object that you want to see. This eye want to see this object basically. Okay. So earlier, if you are placing the object at the near point of this eye, basically this distance will be 25 centimeter. Okay. This distance will be 25 centimeter. Earlier, you have placed the object at the near point, then image where the image is forming behind the retina. But this time, you have placed the object at the near point, and also you have placed a converging lens or convex lens here. So what will happen? This is the nearby object, and from the nearby object, what type of rays are there? Diverging rays are there. These are the diverging rays. Now, due to this lens, these are the diverging rays you can see here. These are the diverging rays. If you will extend, you will see these are the diverging rays. So basically, these rays will be these are the rays. No? These rays will go like this. Okay, these rays will go like this. But as this lens is placed here, as this lens is placed here, L is the lens is placed here. This lens diverge these rays. This is the actual path of the rays. Okay, this is the actual path. This green color is the actual path of the rays due to this nearby object. But this lens diverges these rays like this. Okay, and finally these rays falls on this eye lens. This is the eye lens, and finally the image is formed on the retina. So basically, now again I am telling what is happening here. This is the nearby object, and these are the rays from the nearby object, and these rays are diverged like this. These rays are converged like this. Okay, these rays are converged like this. So basically, this is the convex lens, and this is the object. This is the object this time. So this convex lens will produce a virtual image of this object at this near point of this hypermetropic eye. Okay, basically actual object is this, and here there is an image of this object. Okay, so if here is the image and this is the near point of this eye, so this image will work as an object for this eye lens, and the image can be formed on the retina. Okay, so this hypermetropic eye can see this object which is at a near point near of nearby of this eye, can see clearly. Got it, Azaan?
Yes, sir.
See, here is this nearby object. In actual, the object is here, and this eye want to see this object, and this eye is suffering from hypermetropia. So this is the object at 25 centimeter, but this eye cannot see. So we place a lens, okay, converging lens. So from this object, the rays will be like this. Okay, from this object, the rays will be like this. Okay. So from this object, this is a nearby object. So that is why there are diverging rays like this. Okay. Now here the refraction will takes place. and due to that refraction, the image, and this is a convex lens, and convex lens produces the virtual image also. So this convex lens will produces a virtual image of this object here. Okay, and this image will work as an object for this eye lens. And remember, this is the far point for the myopic eye. This is the far point for the, not the myopic, hypermetropic eye. Far point for hypermetropic eye. So here is first conversion taking place, and here is another conversion taking place. First the rays are converged here and then converged by the eye lens, and finally the image is formed on retina. So you can say correction of the hypermetropia. The convex lens forms a virtual image of the object. Okay, and that object is lying at the near point. Okay, so the image is formed at the near point of the hypermetropic eye. Okay, so if the image is formed at the near point of the hypermetropic eye, so this image will work as a object for this eye lens. So the image will be formed on the retina, and this hypermetropic eye also can see this object clearly. Okay, Azaan, in the last class you have not completed this.
Done, sir.
Okay, can you tell me what will be the object distance in this case? Basically, this is the someone can ask you also. This will be the
What, sir?
object distance. I am just asking. This is what will be the object distance. So basically, this is the object distance. Na?
Yes, sir.
This is the object distance. What is the this? What is this object distance? Infinity,
Yes, sir.
because this object is at infinity. And what is the image distance? So this will be the image distance. Far point of the, this will be the image distance. This is V. So this will be used when we will calculate the power. So remember, in case in for the correction of the myopia, the image distance is the near point of the myopic eye, and the object distance is infinity.
Okay, sir.
Okay, so note down this.
Sir, can you scroll down?
Completed.
No, sir. Just a minute.
Scroll down.
Yes, sir.
Completed, Azaan?
Yes, sir. Done.
Okay, so this diagram also. Just a minute. Basically, this lens is producing the image of this object at the near point of this eye. So Azan, tomorrow na we will start the height and distance, okay? In maths,
Okay, sir.
because we have completed the introduction of trigonometry, and height and distance is basically also called the application of trigonometry. So there the trigonometry will be used. Okay. In height and distance, we will use the trigonometry. So trigonometry we have completed. So that is why I am starting height and distance.